Okay, welcome back. We're going to actually calculate a regression model here and show you how that works and walk you through the equations, which are super simple. There's lots of different ways to do these equations and calculations, and some of them are more labor intensive and some of them are easy, but it's not always intuitively clear why that would be the case. We're going to go with the easy ones that are not intuitive because we want you to be able to do this without having to use a computer to do it. So we're going to go ahead with that. And just like with ANOVA, I'm just going to ask you to trust me that these equations actually work instead of taking you through from the idea through the derivation and the algebra to get to the equation, okay? If you really are super interested, we can find you a stats book. You can take a look at that if you want. All right, so remember this is the equation that we're trying to get to because we want to find out what that line is, okay? So we have our predicted dependent variable, we have our independent variable x, and then we have the slope of the line here, which is our beta, and then alpha is the intercept. Okay, so that's what we're working toward. So we got to figure out how to calculate those. To start off, we're going to have a little sample or example data set here, and this example concerns how long people have been working in a job and what their evaluation score is. So every year at the end of the year, they get an evaluation and there's a score associated with it, okay? So you might think, I don't know, maybe the longer people are working, the better they get at the job. I don't know, maybe that's your hypothesis. Maybe you have a different hypothesis. Maybe they get tired of the job and so their evaluation goes down over time, something like that. So maybe you should have a two-tailed hypothesis since you really don't know which way it's going to go. All right, so here's their years. So this person has been working there for 10 years. And they got a 22 on their evaluation. Not very good. That person might be a candidate for a layoff. Okay. This person's been working 11 years. They got a 49, and so on. Go down the data. Okay. We have 10 people in our data set. All right. I'll get to these other columns here in just a second. All right. So what do we need in order to calculate this? Well, one thing we're going to do is we're going to calculate a formula for that beta. Okay. Once we have that beta, though, it's really easy to find out what the alpha is because we just have to plug the beta in here and rearrange the data a little bit. So if we want to figure out what the alpha is, all we need to do is take the mean of our y values and then we subtract. Why can't I make a beta today? I'm having a lot of trouble with that. You should have seen before we got started. I had to practice. Okay. And we take the mean of the x and we plug it in with the beta that we just calculated. We haven't done it yet, but we're going to in just a second. And then we just subtract and we'll get the alpha. Very simple. All right. All right. So what's the formula for the beta? That's the one big thing that we got to do. Hey, I made it a good one. Yay. Okay. It's n times the sum of x times y. Okay, minus the sum of the x's times the sum of the y's. Okay. And that's divided by n times the sum of the x's squared minus the sum of the x's. Sum them up first, then square them. Okay? Very simple. All we're doing is taking stuff from over here and sticking it in, sticking it in, sticking it in. Okay? So let me just go over and calculate these different things so we can see what's going on. First of all, our n equals 10. We have 10 people in our sample. All right? So we've got that piece already. Now we need the sum of x times y. So let's go ahead and calculate x times y so we can add those up. And I've already done that for you here. So 10, just to show you how I got it, 10 times 22 equals 220. 11 times 49 equals 539, and so on. So there's all the x times y for each one of our cases. And then I need to add them up. I have my sigma, so that means I'm going to add them up. And that turns out to be, I already did it for you, 2792. That's the sum of x times y. So that's what I'm going to plug in there in just a second. What else do I need? I need the sum of all the x's right here, this piece right here, the sum of all the x's. So here's my x's, and so I just add those all up, and that turns out to be 69. And then I need the sum of the y's right here. Okay, so here's my y's, and I'm just going to add those up. 448, my dependent variable. And let's see, what else do I need? Let's see, I've got sum of x here. So I already have that. I just did that, sum of x. And then right here, I need the sum of x squared. So I've got to calculate x squared first and then sum those up. So that's this column here. Here's my x squared. So I just did this for you already. 10 squared is 100. 11 squared is 121. 5 squared is 25, and so forth. Okay? And then I just need to add all those up so I can plug that in there. And that turns out to be 613. Okay? You can whip out your calculator and check and make sure I did that right. Okay? So now let's just plug them in so we can get our beta. It's a very easy thing to do. Okay, so n is 10. So 10 times the sum of x times y. The sum of x times y is 2,792. And then I'm going to subtract the sum of x times the sum of y. So 69 times 448. Okay. And then I got n again down here, 10 times the sum of the x squared. So that's this number here, 613. And then I'm going to subtract. This time I'm going to take the sum of x first. I'm going to add them up, and then I'm going to square them. So that's this here, 69 squared. Right? That's it. And all I got to do is just crank all that through my calculator, which I have done here. And so obviously that's 27920 minus, this is 30,912. This is obviously 6,130 minus, this is, turns out to be 4,761. And let's see, I'll just finish it up over here so we can see. So this is minus 2992. You got to make sure you keep track of your negative signs in this. So I'm subtracting a bigger number from a smaller number, so I'm going to end up with a negative number there. That's important. And then down here, I've got 1,369. And so then I just divide that out, and the answer is negative 2.19. Negative 2.19. That's the slope. What does that mean? That means when I draw my graph, it's going to look like this, right? This is the years going up, and this is the evaluation. And so what's happening here is that as you accrue more years of experience, your evaluation actually goes down. Right? That's what the negative relationship means. Whenever you see a negative relationship like that, the slope is going to be like that. That's interesting. How much is it going down? Well, for every additional year you work, a 1 unit change in the independent variable years, so I add 1 more year of experience, my evaluation score on the average is going to go down 2.19. That's what that slope means. Okay? All right, so then the last little piece I have to figure out is my alpha. And it's very easy to do that. So I just need the mean of y and the mean of x, and then I just calculated beta right here. This is my beta. All right, so I just plug those in. Now I haven't calculated my means yet, but I made it easy for myself by having 10 cases. So I know the mean years is 6.9, and I know the mean evaluation score is 44.8. Okay, so now I just need to calculate alpha. It's a very simple thing to do. I'll go back to my formula right here and see what pieces I need in order to calculate my alpha. So I need the mean of y, and I need the mean of x, okay? All right, so the mean of y is 44.8, and then I'm going to subtract the beta. The beta is negative 2.19. And then I'm going to multiply it by the mean of x. The mean of x is 6.9. Okay? All right, and then when I do that, I get 44.8 plus What is the number I get? Where did you go? Oh, this is 15.1. And that equals 59.9. There we go. So that's the alpha. And so my regression equation is y hat equals 59.9 minus 2.19 times x. Ta-da! There's your regression equation. And it's vaguely represented by this line right here. And it means if I kept drawing this line up till it crossed this axis here, which is 0 years of service, it would predict a value of 59.9. And then it just keeps going down from 59.9 as people gather more experience. That's what's happening. Okay? That's it. You just calculated a regression model. So next time we have to talk about how to do some significance testing on this. But you've got the basic idea down, and you've got all the apparatus you need to actually calculate regression models. Super useful kind of thing in many, many circumstances in life and work and so forth. So we'll see you next time to do the significance testing on this.